Complex plane is used in graph theory and complex analysis.
Welcome back to Caroline and Katie's Math channel.
So, what is the complex plane?
Complex plane is a geometric representation of complex numbers.
Plotting a complex number. Step 1. Make sure your complex number is in the form a plus bi. Step 2. Identify the real component, a, and the imaginary component, bi. Step 3. On the horizontal/real axis, plot the a coordinate. Step 4. On the vertical/imaginary axis, plot the bi coordinate. Then find the intersection point. This is your new complex number.
Now it's time for some practice problems.
Here we see a complex triangle made up of 3 complex points. But how did we get these points? Let's start with an example problem of 6 plus 4i. Following our step-by-step guide, the first step is to identify the key parts of our complex number, the real and imaginary. In this case, 6 would be our real number and 4i would be our imaginary number. Next, we look to our graph. On the horizontal or real axis, the first step is to move 6 spaces over to the right. 1, 2, 3, 4, 5, 6, which gives us our real point. And then on the vertical or imaginary axis, 1, 2, 3, 4, until we get 4i. Finally, we find the intersection of these 2 points to give us our complex number 6 plus 4i.
Now, see if you can graph the coordinate -3 plus 1i.
Now we will use our simple step-by-step process to try and plot the complex point -3 plus 1i. We'll skip the first step and move straight to the second step. Identify the real component a and the imaginary component bi. In this case, -3 is our real component and 1i is our imaginary component. So, first we will use our horizontal axis and move 3 spaces to the left, which gives us -3. Next, on the vertical or imaginary axis, we will move up 1 to give us 1i. Finally, we will find the intersection of these 2 points, which gives us the coordinate point -3 plus 1i on the complex plane, giving us our new complex number -3 plus 1i. Now we will run through one last example problem to solidify our understanding on plotting a complex number on the complex plane. In this case, our number is 2 minus 5i. Our real component is 2, and our imaginary component is -5i. So first, on the horizontal or real axis, we will move 2 spaces to the right. Next, on our vertical axis, we will move 1, 2, 3, 4, 5 spaces down to give us -5i. Next, we find the intersection of these 2 points at 2 minus 5i, giving us our new complex number. Now that we have all 3 complex numbers, we can see we have completed a complex triangle.
Complex plane is utilized in many scientific areas, such as control theory, signal processing, quantum mechanics, vibration analysis, and cartography. Each of these involve the use of multiple complex parts, which cannot be represented on a normal place. To more easily visualize this concept, we will narrow in on the topic of electromagnetism. Electromagnetism is usually described by 2 quantities: electric field strength, which is generated by a flow of ferromagnetic materials and a combination of kinetic energy beneath Earth's crust, and magnetic field strength. Scientists depict this concept as a combination of complex parts. In this way, it can be easily visualized. A being electric field strength and Bi being the product, magnetic field strength. The project has really helped us understand and visualize complex numbers. We got a little bit in depth into imaginary numbers earlier this year, but I never really understood, how to graph it or what they looked like. I knew that they were negative square root numbers, but the complex plane has really helped me visualize this, and so any further knowledge on it, I will be able to have a good firm basis of, how to depict it in a geometric way.
During our time studying the complex plane, I have discovered another layer of understanding that adds on to all the previous graphing that we have done. In addition, I first thought it was very simple, but now I know that it is truly the foundation for many forms of mathematics that utilize the complex plane and complex numbers, including quantum physics, which I find really interesting and will help me in further studying that I do in this area.